That's correct.
So to get the information, I'm sure he's going to give you a lot of it. To get more information, network flow analysis by Michael Lucas from No Starch Press. Yeah, you can have the book because you asked nicely. No. I hurt somebody throwing a book a couple years ago. I'm not doing that again. All right, with no further ado, Rich Friedberg.
Thank you. You guys hear me all right? Thumbs up? All right. So let me see how everybody's doing. How are the hangovers from yesterday? Folks starting to recover? We're getting close to lunch? More importantly, who started drinking already? All right, we got a couple. So I got briefed last night on a couple of Shmoocon drinking games going on. So I'll see if I can help you guys out during the talk, starting right meow. That's for you. All right, so what are we going to talk about today? We're going to talk about NetFlow. We're going to go through quickly what it is, why you should care. It ties in great to Richard's presentation that he just gave. I think he set up a great context for the bad actors that are there and how kind of the common habits that we put forth for a good security program still tend to miss them. Since this is the Build It talk, we'll talk about a couple tools that are freely available for you guys to use. We'll go through the capabilities of those tools and a couple examples. We'll go through a almost live demo, and what I mean by that is we've got some stuff running over in the Shmoocon labs, but I don't trust connectivity between here and there, so I ran and took screenshots right before the talk to guarantee that this thing actually works. We'll go through how you can build it, how you can get set up with this stuff on your own, and then where you can go for more information. So what is NetFlow? NetFlow, very simply, is a brief summarization of network traffic. So we're really talking about header information, source, destination, protocol, transport, source port, destination port, time and date, flags on the protocol, number of packets sent, number of bytes sent. Real simple summary information. So real quick, how many folks here run NetFlow on their networks? All right, good. That's increasing year over year. How many folks use it for not just network monitoring or billing, but also for security purposes? All right, that's probably about 2/3 of the folks that had their hands up the first time. So not bad, not bad. So why do we look at NetFlow? One, it's cheap. It's quick. We're talking about a lot of small data. There's plenty of tools that do this stuff really cheap. There's very minimal privacy concerns. Right? We don't have to worry about capturing PII information. We stand up NetFlow sensors. We're not going to capture folks' social security numbers or their healthcare records or things like that. So no extra protections on the data sets or the samples that we worry about. It scales. We can deploy this stuff on very, very large links and collect some very large data sets better than we can with a lot of other systems. And that ends up giving us a very large, rich data set to run some fairly interesting analytics against. So what are the cons? Well, we don't get that payload information, so we are kind of forced to figure out what we can based on summaries. And the other con is, well, we got a very large data set, and as Richard mentioned before, that can be kind of daunting when you're going through millions or billions or trillions of flow records. So we'll talk a little bit about how to manage that as we go forward. So talking about kind of the Legos and building blocks, NetFlow is one of my favorites because it's incredibly versatile. So here's kind of a short sampling of things you can use it for. We'll walk through some of these today, but there's the traditional network billing, which is what NetFlow was originally invented to be used for. You can track utilization. You can get a good idea of what's on your network. You can do profiling of where are my web servers, where are my mail servers, and then when things behave slightly differently than what you expect, they'll kind of stand out. You can look for data loss and exfil stuff, right? You start seeing some particularly large flows coming from your user segment, perhaps they're worth looking into. You can do a lot of malware detection. So Richard talked previously about sharing information, looking at indicators, right? Friend says he got popped with some malware. NetFlow is a great resource to go back and say, hey, did I have any hosts that talk to those same indicators? You can run things against watch lists and intrusion sets. So if that 3-letter agency comes and knocks on your door and says, hey, we've seen this activity, granted it was 6 months ago, NetFlow is an excellent resource to go back and pull that history from to really find out what's going on. You can track botnets, you can look at kind of acceptable use monitoring, you can troubleshoot applications, and most importantly, after an incident, it's a great record to go back and figure out what really happened. So really, what does this all boil down to? Visibility, right? You've got to know your network. As Mudge talked about last night, just kind of relying on signature-based methods in your security program isn't sufficient, right? You're going to get popped. It's going to happen. You need to be able to look beyond just what you've captured with signatures to figure out what really happened and what's going on. So why is NetFlow useful? Kind of from a storage perspective, you can keep a lot of it around for a long time without spending a lot of cache. So just to think about a 100 meg link, if you want to keep a month around off of a fully saturated link, which really isn't going to happen, you're only talking about 50 gigs worth of data. That's cheap. Storage is cheap. So bring that up to some larger links, right? A gigi link, assuming it's fully saturated, still only half a terabyte for a month. You can go all the way up to a 10 gigi link, and you're still only talking about 5 terabytes. Now, that's reasonable given today's storage prices, and certainly a lot more reasonable than full packet capture. So we'll transition here to start talking about tools that you can use to do collection and analysis of NetFlow data. So one more show of hands, who's familiar with CERT's NetFlow toolset? So Silk and YAF and that sort of stuff. All right, so I think we got about 20% of folks. So some of this will be repetitive for you guys, but there's also some new stuff, and hopefully we'll give kind of a brain teaser on some new interesting ways you can use the same tool set. So the first tool is YAF, stands for yet another flow meter. This is kind of our basic sensor tech. So what is it? It captures off the network. We can read straight off of libpcap. We have drivers to support DAG cards, to support Napatech cards, or you can kind of replay off of a dump file and generate flow from there. So into the sensor and out pops IPFix, the IATF standard for flow data. And from there, you can take your IPFix data and do a number of different things with it. So Silk is the tool set that we'll talk about a little later. It stands for the System for Internet Level Knowledge, and that's another free tool set that kind of provides the collection and analytics foundation for some of this NetFlow activity we'll talk about. So what's been happening with YAF recently? Well, it started off just as a NetFlow collector. We collected headers and kind of thought about what's the full spectrum of network monitoring, right? So you've got kind of basic header information on your left, full PCAP capture on the right, right? Clearly, that's a richer data set. You get a lot more value out of PCAP, but it's expensive. That's a heck of a lot of storage. There's privacy concerns about what you're storing. Maybe there's something in the middle, right? If we can kind of analyze that data as it's coming through, pull out metadata from the full capture, but only store that metadata and kind of marry it up with the flow as an index, you get kind of a lot closer in terms of the value line towards that right edge. So recent changes to YAF include a lot of application labeling. So instead of just merely marking a flow with what port it's on, let's mark it with what port it's on and kind of what protocol do we think that was. So somebody's running a web server on port 81, it'll map it as web traffic. So we've got a full list of applications that we can label, and again, these get populated into the flow record. So beyond that, let's delve a little deeper. So YAF now also supports full DNS capture. We can capture all records or just authoritative and annexed domain responses. So why is this useful? Well, who's tried to turn on DNS logging on a fairly busy DNS server? It doesn't work so well, right? So easy to stand up a YAF sensor right next to it, capture all the queries, and dump them out for analysis. No impact, no routers going boom, no DNS servers going boom. Web traffic. So we'll pull a bunch of stuff off of the HTTP headers. We can get the server, user agent, the refer, location, et cetera, et cetera, et cetera. Useful to have when kind of mining, especially as Richard mentioned before, the user agent. You know, nice to know what's on your network, what's popping on and off your network, get a general idea of what your users are using. We can also do some further capture on a number of other protocols, FTP, mail, and recent projects working on SSL and TLS capture and trying to grab X509 certificates to keep an eye on. So what do you do with the YAF output? Well, we dump it into Silk, which is, as I mentioned before, our set of collection and analysis tools. Practically, it's about 30 command line utilities. If you are familiar with the Unix environment, they're pretty easy to pick up. So kind of the tool model is listed here below. You've got your network capture, YAF is your sensor, feeds into collection for Silk, and then you've got a series of command line tools. So when Silk stores things on disk, what's it kind of look like? Well, from your configured root directory, we break things up by sensor, and then by sensor into subfolders based on your traffic type. So inbound traffic, inbound web traffic, outbound web traffic. We tried to come up with the kind of large buckets where people generally run queries. Right? So if you are interested in delving deeper into web traffic, things are already separated. Your queries run a heck of a lot faster. You don't have to mine through multiple files just looking for that traffic. From there, they're further broken down by year, month, and day. So again, the tool sets can easily select which files they need to run through. To run through some of the basic commands, we won't go through these in significant detail, but there's a filter command. This is really your first line filter. What protocols do I want to look at? What time frame do I want to look at? What ports do I want to look at? There's a sorting command, a RW cut command, which will print things out in plain text for you to use in whatever other reporting utilities you want. There's some kind of unique grouping command. There's a counting command, and what one is particularly useful is the RW stats command, just to pull kind of top end lists, bottom end lists, so you can see any abnormal behavior that stands out, right? Who's the top talker on your network? What are the top ports going on? What's the top talker in a particular business unit off of the end user segment, right? Just kind of places to start looking for anything that might be anomalous. So with 30 or so Unix commands to pour through all this data, we've certainly gotten some feedback that this can be a little painful. Oddly enough, we also run into a lot of network analysts that aren't comfortable with the Unix command line. So for those guys, we've written a front end that we call iSilk. Kind of makes it easier. It's kind of training wheels to get started with flow analysis. There's menus and GUIs to kind of drive through your query building. And it also builds that, what database? So it's the flat file structure that I mentioned before. So if you go back here, they're stored in flat files. They're 53-byte records if you look at the data that we store. And then from there, we will actually pull the common elements out and store them in the header of that particular file. So if you were to kind of follow this directory tree, you end up with a bunch of hourly files in these folders with a header that has kind of the sensor name and the aggregate similarities on time and date stamp. And then from there, you end up with 22-byte records in each file that we further compress and get about 50% compression ratio. So that's actually how we end up with those sizes that were on the previous slide. Good? So back to iSilk. It's kind of nice training wheels for a new analyst, helps them get familiar with the command line tools. They can go through and build this, use the wizard to build their commands, and it shows them what commands it's actually running down at the bottom. So it's a good way to get familiar with the full set of commands. And we started adding some basic viz stuff in there. So you want to create some nice charts for management, or you want to look at some of the time series plots that we'll run through later. It's a nice, useful, easy way to do it. For better or worse, if you're so interested, you can also export things into Excel and kind of use basic Excel functions to do a couple of graphs as well. So how does it work? It's got a front end that literally just SSHs to the back end where Silk is running, executes the commands for you, and pulls the data set back for your display. Runs on Windows, Mac, or Linux. It's a Python-based front end. It's a screenshot of the query builder. So here you can see somebody selecting a couple days in December, and it looks like they're looking for web traffic. And as I mentioned before, you can see at the bottom, it's showing you that RW filter command that it's actually running on the back end. So you can see there that it's actually selecting those buckets of traffic type, looking for outbound traffic, outbound web traffic, inbound and inbound web traffic from a start date, end date, looking for destination or source ports that relate to any sort of web traffic. And you're passing your output, in this case, that's going to come to standard out. So it's the second screen of the query builder where you can dive a little deeper and choose what protocols you're looking for. You can select which TCP flags you want to filter things down for, and also put in some things around country codes and sizes. Here's a typical output of a query. This one's actually using the rwunique command to kind of count the records from destination IPs. So just kind of a top-end list. But what's interesting to note on this slide is we do keep track of what queries you're running on the left-hand side. So it's easy to kind of drill down and pivot on a particular IP address or particular protocol and kind of go back to where you were in the workflow, just kind of keeping track of what's going on from an analyst perspective. So for those of you that do NetFlow analysis, and either with these tools or a similar tool set, what's kind of the key problem with doing everything like this? So the gripe is it's slow and it's not in real time, right? So this is analyst after the fact going through, pouring through traffic to figure out what's going on. So we've had some recent projects to kind of think about how we solve that. And the solution so far has been what we call the silk analysis pipeline. So if you remember that chain of tools that we listed before where YAF is collecting the data, spitting out IPFix, shipping it over to silk to be written to disk, what if we plug something else in there, right? Kind of inline stream processing of the flow data as it's written to disk. So this kind of moves us away from that retrospective analysis to something close to near real time. And we'll go through some of the capabilities of pipeline. So pipeline starts off with a series of filters, right? You don't want to look at every single flow and run it against your evaluation criteria. So let's try to whittle down what you're interested in, what's related to those evaluation criteria that you're going to run. Run your evaluations, and then you've got a couple options for what that output looks like. So, as I mentioned before, each evaluation is associated with its own filter. So filter down the traffic. And then each filter is specified in that config file, in pipeline's config file. And you've got a whole set of operators that you can use. And it's your kind of typical set of what you'd expect against any record in the flow, or any field in the flow. So in a list, not in a list, source port greater than something, destination port greater than something, source port 22, you name it. So after you filter down what traffic you want pipeline to actually look at, you've got a series of evaluations that you can configure. So you can do something like alert if you see this sort of traffic across a 5-minute interval. Alert if you see something greater than a particular size. And these evaluations can actually be chained together. So you can do any sort of combination of events. And we'll go through a couple more examples on the next slide. So some interesting things that we've done with pipeline so far. First is finite state beacon detection, right? So let's keep track of all the flows. If we see a similar flow happen again across a fairly standard time interval, perhaps that's something to keep an eye on. Does it keep happening, right? Does that same flow happen every 5 minutes? Is it the same size or a similar size? And perhaps that warrants some further investigation. You can do some sensor outage detection, just kind of basic network monitoring, right? You see traffic volumes start to slow down or drop off completely, spit out an alert. We've got some algorithms around IPv6 tunnel detection, looking for passive FTP. Most common is watchlist hits, right? You are talking to your buddy about that piece of malware, or that 3-letter agency came by and gave you a set of IP addresses that they were concerned about that they saw interacting with your network, right? Besides just running the retrospective analysis or cronning a batch job to run nightly looking for that stuff, put it in pipeline, get those alerts coming out, and get somebody reacting a little faster if you see that traffic. And then, of course, simple things like aggregate flow counts. So after you've got pipeline configured for what you're looking for, what do you do with it? So we've got an alerting library that's pretty configurable. You can write to any sort of text file. You can write to CEF for ingest into ArcSight. You can feed remedy and create tickets out of this stuff. It's quite configurable. So what's that whole suite of tools look like when you put it together? You've got your network capture, and YAF is your sensor, outputting IPFix, and from there you can analyze some of those deep packet inspection capabilities that we talked about. And at the same time, you have IPFix feeding pipeline and then into the Silk repository. And from there, you have your command line tools, the iSilk GUI that we talked about, and your analyst scripts. So let's talk about some of the things that you can do with this tech. So Prism is a script that we released about a year or so ago to take a look at traffic as it passes, or as the queries run, and kind of apply filters of known traffic to weed things down, right? So let's take a big query of network data. Let's pull out the web traffic and see what it looks like. Let's pull out the FTP traffic and see what it looks like. Pull out the DNS traffic, and then take a look at a graph of kind of what's left, right? What's the remainder of that traffic? Is there anything interesting that an analyst wants to kind of dive deeper into to see if there's anything funny going on? So practically, what does that look like? Here's an example where you've got the total amount of traffic at the top. Clearly, you can see the 24th and 25th there must be on a weekend. Down below, we've pulled out all of the client web traffic. And at the bottom, I guess to break down the top and bottom parts above the x-axis, underneath is inbound traffic, above is outbound traffic. So the next graph down walks through web traffic, served web traffic, and then other. So just taking a look at the other graph, you can see on the weekend there's quite a bit of outbound traffic, right? That would catch attention, right? Perhaps that's something to take a closer look at. So kind of as a first swag of what's going on with the network, what do I want to look at? How do I make sense of all this NetFlow data? You know, a decent place to start. So Prism takes a look at a very wide set of data, right? Apply that same kind of time series plot to a narrower set of data, right? Let's say that three-letter agency came to you with a list of IPs they were concerned about, or you've got your list from shadowserver.org or any other threat feed. You run a couple RW filter queries to see if there is traffic from any of those IP addresses, and you get a nice long listing of NetFlow records. But how do you make sense of it, right? You don't want to have to pour through all of those text responses line by line. So just throw them out on a bunch of time series plots like this, and certain things start to stand out. This plot here is actually from a configure infection, but you can clearly see routine beaconing, inbound and outbound traffic, and perhaps it's worth taking a closer look at. So other things you can use this stuff for. Who talked to who, right? If you find out that a box got popped, perhaps you want to know what other boxes that machine talked to. So if you get something like the graph on the right, perhaps you should be a little worried. So perhaps you've got an employee that's under disciplinary action, right? What has he been up to? What's his box been talking to? Does he have any large transfers going on? You know, things to keep an eye on. If you find a box that's got popped, that has been popped, who else has talked to the same indicators, right? If you do some surface analysis on malware that you found come in through a phishing attack, what are the indicators, right? What IP addresses did it talk to? Run those through your NetFlow log, right? Go back 6 months. Who else has been popped with the same thing on your network that you didn't have signatures for? Who are the top talkers on your network, right? Things that just stand out as abnormal behavior, right? Good first places to look. So we've gone through a couple examples that include visualization, and some of that stuff can be kind of painful to pull the text data out, throw it to something like NewPlot, or even dump it into Excel and look at graphs in that manner. So we've released what we call Rayon, which is a visual library and set of command line tools to try to make these sort of visualizations easy. So the goal is really to improve the uptake of these analytics, let SOC analysts perform them easily, right? Just throw the call on the bottom of your script. And lastly, we've included it into iSilk. So as you're kind of pivoting around in those workflows, you want to generate some interesting viz to either help you kind of visualize what's going on or just generate reports for senior management. So what can you do with flow data and other data sources? So we talked earlier about using YAF to capture DNS data. So let's say you've got a big collection of DNS logs. Sorry, I can't read that from here. So that's a good question. It depends on how much deep packet inspection you're doing. But we are capturing all of the conference traffic on just kind of a small Mac Mini equivalent box that's not breaking a sweat. Napatech was actually out at a conference we had 2 weeks ago, showing one of their capture cards running YAF at 10 gig, and YAF was taking up less than 100% of CPU on a single core. Correct. Correct. So, I mean, monitoring a 100 meg link, you can probably get away with commodity hardware. You get much above that, and you probably want to start looking at dedicated capture cards to offload some of that resource utilization. So, back to data fusion. So, let's say you've got your big set of DNS data. It's pretty easy to go through there and spot fast flux domains. So you find a bunch of fast flux domains. You figure out what IPs they resolve to at a particular given time. Let's find out who perhaps talked to those IP addresses. And again, Flow is a perfect kind of security camera DVR of network traffic, if you will, to go back in time and see who actually talked to those addresses. As I mentioned before, malware analysis, right? Let's say you've got a decent sized malware analysis shop. You do some surface analysis of some new binaries, find out it does beacon out, it does talk to some command and control networks. Let's figure out who on your network has actually talked to those. And again, you can do it kind of the retrospective analysis using Silk scripts against your repository, and you can configure pipeline alerts based on kind of ongoing traffic to see if anybody else hits it in the future. And again, you can feed some of this stuff into a SIM for further correlation, right? Let's say you run the beacon detection script and you've got a set of IPs you're concerned are beaconing. Let's see if there are also any IDS alerts from those same IPs, right? Correlating kind of some of these simple analytics really adds up when they start firing on more than one analytic. So if you remember back on the tools slide, let me flip back here real quick. We mentioned that YAF spits out IPFix and now those additional deep packet inspection capabilities and kind of leads to that protocol analysis box. So that's an area where we are currently developing tools to figure out how to make sense of that data. How do we organize it? How do we analyze it? How do we store it? So we are currently alpha testing a new product that we call the YAF Inspector. And for those familiar with Pittsburgh, we've had to shorten it to the Y Inspector, just so people can say it's the Yins Spector. Well deserved. Well deserved. So as I mentioned before, this is what we actually have running over in the Shmoocon Labs room just next door, where we have YAF feeding a database that the Inspector front end is running against. So a couple screenshots that I took just about an hour before the talk. So a basic query interface, what do you want to look for? And again, you're kind of using your typical flow fields as indexes when you run through, but you can also provide additional information around protocols, and kind of those deep packet inspection capabilities that we talked about earlier. So it also creates a bunch of top 10 lists based on those capabilities we talked about before. So here's the top 10 user agent strings that we've seen at Shmoocon since about 3 o'clock yesterday. And I guess it's not too surprising that there's a large amount of Mac users. I think it was surprising to me that iPhones on the wireless network were actually the third. We've got, looks like a bunch of Unix machines in the 4th and 5th slot, your Android phones, and then some more Unix boxes, but not a steady presence of Windows machines on the wireless network. Perhaps people are learning year over year. No sheep, no sheep. Yet. But as Richard said in the previous talk, right, this is a great list to keep an eye on, right? You start seeing a bunch of different user agents pop on your network, perhaps you should investigate a little more. So you can kind of baseline what you're seeing on your network, keep track of how that's changing over time, and kind of chase down things as needed. So the next top 10 chart is a list of the top refers. So it looks like a lot of people coming off Linux.com, a whole lot of people tweeting. Not surprising, a lot of Ustream hits, and a lot of people reading the news. Next top 10 list is a list of applications, and what's interesting to note here is this isn't necessarily the port, but this is the application that relates to that port, right? So DNS, web, secure web, bunch of Windows file sharing, a little bit of SSH and FTP traffic. So let's take a look at this in a table and add in what the actual port was. So here we can see YAF has actually figured out that there's web traffic on ports other than 80. Shocking. Right, so here we can see a bunch of people web browsing on 8080, 2080, 8081. We see a whole bunch of DNS traffic on 53. And the one below that I thought was actually pretty interesting. We see a heck of a lot of DNS traffic on port 5355. Is that anybody in here? I'm just curious what it is. Pardon? Over 5355? So as I mentioned before, just kind of looking at top talker lists. So here are the top talkers on the Shmoocon network from Friday afternoon until about an hour ago. Has anybody been using 10.10.0.10? The Shmoocon Labs guys mentioned that was just an IP address on the Open Wireless Network. Scanner? Oh, that explains it. That explains it. So, as this is a build it talk, I figured we should talk about how you actually build this stuff. So all the tools are available on tools.netsa.cert.org. We provide the full source, we provide RPMs, and if that's still too hard for you, we also provide a live CD. You can burn it onto I guess CD is incorrect, it's a live DVD. But you can download the live DVD, burn it, and kind of pop it in and be capturing immediately. So it boots up, loads YAF and starts capturing traffic. It has its own Silk install on the live CD, and we'll start populating the Silk database. So interesting to have for kind of an incident response kit as well, right? You go into a site, you want to start capturing NetFlow data. It's an easy way to get a sensor up real quick, even if you kind of have to just steal a machine off the client's network to get going. Up on the website, we also have a couple reference data sets. So if you're trying to get your feet wet with NetFlow analysis, there's some data sets on there that have some interesting things. So you can play around with the command line utilities, you can play around with iSilk, and kind of see what you can find before you're able to deploy this stuff on your home network. So where to go for more information? Back on the website, there's the full software. We've got extensive documentation, including an analysis handbook that really runs through some of those common analytical techniques that we talked about and gets into more in-depth usage of kind of those 30+ command line tools. There's an extensive installation guide, and what we've added over the last couple months is a large set of online training. And this is kind of recorded instructor-led training, walking through slide decks, as well as a full interactive lab. So it'll actually spawn up some VMs on the back end and let you play around with a full Silk environment and run a bunch of sample queries. On the website, you'll also find a wiki that has a bunch of tooltips for common analytics that folks have written. So as we mentioned before, kind of those command line tools are highly flexible and customizable, so it's kind of common for folks to write shell scripts around kind of nested calls to do a variety of analytics, and we try to get a lot of them posted up on the wiki. And then some of those scripts that we've developed, we're in process of cleaning up and refining that code to get them online for folks to use. If you're really interested in delving deeper into NetFlow analytics, we host a conference every January. Unfortunately, we just missed this year's. It was 2 weeks ago out in Salt Lake City. But it's a great conference that kind of ties together academia, industry, government use to kind of all get together and talk about how they're using NetFlow, how they're doing analytics, and kind of how they apply indicators to the data sets. How they mine data and do statistical analysis against some of these particularly large data sets. And lastly, I have to gratuitously plug that CERT is hiring, both in our Pittsburgh office and we have an Arlington office here in the DC area. So with that, I've actually run through this stuff pretty quick, so we've got plenty of time for questions and answers, and a last plug for the Steelers for next week. So plenty of time. Questions? Jill?
Tech cards, have you guys thought about moving some of the analysis onto the actual tech card to speed up real-time analysis?
So we have. So CERT tries to stay a little vendor neutral. So if folks want to submit code to any of these projects, pardon? The question was, have we looked into offloading analytics onto specialized hardware, right? So we talked about using capture cards for YAF to offload resources there. What about on the analytics side of the house? And the answer is yes. In a lot of cases, it's customer specific. We try to stay vendor neutral, so not really announcing some of that optimization that goes on, but certainly it makes a lot of sense. There's a lot of advancements in kind of back-end storage technology and optimized hardware, particularly of late, that comes into play. Yes, sir.
Does the online training and/or the training you offer through SEI give training in what to look for and user specific for how to do that?
To some extent. So there's a number of kind of common use cases that we walk through. And as I mentioned before, we try to put some of those analytics and kind of what to watch for in the wiki. And we're in the process of standing up a new blog where I think we're going to walk through more of those analytic techniques.
Presentation has some intriguing things that really hit on and resonate with me. But I always struggle to kind of translate that into how do I do this.
Certainly. So we're trying to get better about sharing some of those scripts and analytical techniques within the wiki. So stay tuned, keep an eye on the website. Yes, sir.
So you showed a bunch of those standards for content and consumer residents are very involved. So usually baseline has to be higher than those network based now. Is anybody doing anything with baselining against those themselves, or like the first fire RNA stuff where you're collecting data about for anomalies against itself over a period of time?
Certainly. So one of the analytics that was on the analysis pipeline slide talks about rogue server detection. So that is actually kind of a two-stage process where you can use a bunch of Silk analytic scripts to profile servers, right? Who's serving up a lot of web traffic, who regularly communicates via FTP, kind of build those baselines, and then tie those baselines into a pipeline configuration file. And if you see kind of deviation from those profiles, perhaps you should throw an alert, feed something into your SIM, throw a ticket into Remedy or something along those lines.
Have you been successful doing that against large number of customers on networks, or usually do it against like 3 or 4 things you know servers?
It's been pretty, the question was, has that been successful against a broad set of hosts or just a small number? It has been successful against some pretty large networks and really trying to profile what's the full set of web servers, what's the full set of mail servers, and then let's fire when that changes or we start seeing mail traffic come from things that we didn't originally think were mail servers. Thank you. Yes, sir.
Does the pipeline support NetFlow 5 to 9 or just IPFix?
So pipeline, that's actually a very good question. I believe it's just IPFix, but it may be all three. I can get back to you.
Would it be on the website?
Yes. Other questions? Yes, sir.
So could you use Silk if you have a large implementation that can already generate flow data instead of setting up the gas sensor?
Yes. So kind of if we run back to that tools slide. So kind of pipeline in the Silk collection infrastructure just expects to receive V5, V9, or IPFix. So you can run the Silk collector itself and feed it things other than YAF. YAF can also take in dump files. So if you have large PCAP captures that you want to populate into a Silk data store, you can use YAF to replay them and generate IPFix that'll feed into Silk too. Yeah. Yes, on the back. IPv6, yes. So the question was, what is the pipeline configuration? It's a text-based configuration that's fairly straightforward. It's almost kind of an English language walkthrough of the Boolean filters and then the evaluations. There's a bunch of examples on the website as well. Yes, sir.
So it would be easy to like define if I wanted to capture some metadata from like email headers, something like that.
Yeah, so that, I mean that goes into YAF's DPI capabilities, but with our SMTP parsing, you can kind of collect that header information. The YAF inspector tool was kind of our alpha release to figure out what to do with that data. So we haven't publicly released kind of any storage mechanism for it, but YAF can certainly capture it and spit it out into kind of an extended IPFix structure. So you can write your own tools to search through it, or we'll hopefully get the Y inspector out soon for folks to play with. More questions? Yes, sir. Mm-hmm. You can configure it, right? So it's literally just a bunch of Python scripts that call RWB filter. So you can go in there and kind of bin things how you want. And we see people break them down kind of by organizational business unit, by port, by protocol, by management team, you name it. Certainly. You can match it against a set and just map the traffic from that set. Yes, sir.
To return to that, yes, we support IPv6. That was just a little bit too fast.
Okay.
Have the multiple headers. Do you have the capability of looking header within header within header to actually identify the HTTP, or are you actually just one deep? Also, especially when you have routing headers or any additional headers. Also, on the IPv4 end-to-end NAT reassembly tools, do you have anything in that space?
So good questions. They were really, how deep do we go with IPv6? Do we go header to header to header? And will we kind of pull down and actually be able to get web headers out of kind of that nest? I don't know the answer. I believe so, but I'm not an IPv6 expert. We do have a white paper that, if it's not on the website, it will be shortly, that goes into kind of in-depth on what the v6 capabilities are. So check it out. If you can't find it, reach out to me. My email address is here at the end, and we'll find it for you. Other questions? Going once, going twice. Thank you, guys. Enjoy lunch.